Hello everyone. We are Group 19. We are presenting Prereq 3 and Credit 4 for water efficiency of LEED certificates. First, let's look at building level water metering. You can find the reference from page 283 to page 286. Uh, First, let's talk about important definitions. Uh, for potable water, it means water meets or exceeds U.S. Environmental Protection Agency drinking water quality standards, or a local equivalent outside U.S., and it is approved for human consumption by the state or local authorities having jurisdiction. It may be supplied from wells or municipal water systems. For public water supply, PWS, it is a system for the provision to the public of water for human consumption through pipes or other constructed conveyances. Such system must have at least 15 service connections or regularly serve at least 25 individuals. And this is adapted from U.S. Environmental Protection Agency. This prerequisite applies to all kinds of construction, including new construction, core and shell, schools, retail, data centers, warehouse and distribution centers, hospitality, and healthcare. The intent is to support water management and identify opportunities for additional water savings by tracking water consumption. Behind this intent is because there are some disparities occur between the plan and actual performance due to several causes, including but not limited to flaws in energy modeling, inadequate commissioning, inaccurate assumptions, a lack of coordination during the transition from construction to operation. So USGBC aims to compare performances to identify high and low performers based on data collected. For the project team, the first thing to improve efficiency about water use is to install meters to track water consumption. The requirements for this prerequisite uh, for building water use, install permanent water meters that measure the total potable water use for the building and associated grounds. Meter data could be monthly or annual summarized. Meter reading can be manual or automated. Then let's talk about step-by-step guidance. The first step is to identify all potable water and uses, both in the building and on the ground. In detail, including consumption for plumbing fixtures, cooling towers, and evaporative condensers, laundering, dishwashing, indoor and outdoor water features, irrigations, exterior cleaning, manufacturing processes. In general, we can find common examples include public water supply, on-site well, on-site potable water treatment system. The second step is to determine scope of public water supply metering if applicable. If all water used is from a public water supply, the owner needs to check these items with the suppliers. Uh, First is the location. It's where the meter will be located. And second is accessibility, how the building manager will reach the meter. And third is reporting, how the meter will be read. It's either manually or remote transmission. The third step is to determine number, location, and type of all meters. Two or more meters are required if the water used is not supplied by public water supply or if the project used multiple sources of potable water. Additionally, a single meter should be installed downstream of multiple potable water suppliers if it is upstream of all project water uses. Also, extra meters could be installed to collect more information or satisfy other requirements. The step 4 is to track water consumption. Begin tracking when achieves LEED certification or at occupancy, whichever comes first. The last step is to share water consumption data with USGBC. The owner should commit to share the data with USGBC either in way of approved data templates or third-party data source for 5 years. Also, project outside US may use Energy Star Portfolio Manager or the manual tracking template to track and report the water consumption to USGBC. For campus, documentation for each building should be submitted. Potable water used for landscape or irrigation should be tracked in any of these 3 ways, including it with a single building, installing a dedicated meter, installing multiple meters. Lastly, the required documentation for this prerequisite, including meter declaration and sharing commitment.
Now let's begin the part of water metering. First, here are 3 important definitions. First, external meters, which means a device installed on the outside of the water pipe to record the volume of water passing through. Second, wet meter, which means a device installed inside the water pipe to record the volume of passing water. Third, reclaimed water, which means wastewater that has been treated and purified for reuse. The credit of water metering is 1 point for all types, including new construction, core and shell, schools, retail, data center, warehouse and distribution centers, hospitality, and healthcare. The intent for water metering is to support water management and identify opportunities for additional water savings by tracking water consumption. It is required to install permanent water meters for at least 2 of the following subsystems. For irrigation, meters serving at least 80% of the area. For indoor plumbing fixtures and fittings, meters serving at least 80% of the indoor fixtures and fitting. For domestic hot water, meter at least 80% of water heating capacity. For boiler with aggregate projected annual water use of 100,000 gallons or more, or boiler of more than 150 kilowatt, and other processed water. For healthcare project, it is required to install meters in any 5 of the following. Please pause the video to read below. Now let's talk about step-by-step guidance. Step 1. Identify candidate systems for submetering. Identify all systems serving the building and grounds, including irrigation, indoor plumbing fixtures, domestic hot water, processed water, reclaimed water, and boiler water. Cooling submeters are addressed separately. Step 2. Determine scope of submetering. Here are 4 basic equations. A. For landscape area, the ratio of metered irrigated area to total irrigated area should be greater than point A. B. For fixtures, the ratio of number of metered indoor fixtures and fittings to total indoor fixtures should be greater than point A. C. For domestic hot water, the ratio of heating capacity of metered domestic water heating units to total heating capacity units should be greater than point A. D. For other processed water, the ratio of daily metered gallons to total expected daily gallons for end uses should be greater than point A. Step 3. Select metering equipment with data logging capacity. The required documentation for all projects is water metering strategy narrative. Some requirements might change a little bit based on project types. Please refer page 315 for detailed information. In the end, please look at this sample question. Potable water comes from what sources? Choose two options. Wells, cooling towers, municipal water supply, or stormwater systems. The answer is wells and municipal water supply. Thanks for your attention and good luck on quizzes and the GA exam.